Hi, this is Miss Sebastian. We're going to look at Unit 2, Measurement, and Lesson 13, the Unit Test. So your first question is, what solid has one base that is a triangle and three lateral surfaces that are triangles? We talked about in one of the earlier lessons that one base is always a pyramid, and then the figure is named after whatever base it has. So we have a pyramid because it only has one base, and then the base is a triangle. So it will be triangular pyramid, or A. A solid figure with two parallel and congruent circular bases can be called what? Remember, anything with two bases cannot be a pyramid, but this one is circular bases. So we have either a cone or a cylinder. A cone only has one base, whereas a cylinder has two bases. So this one would be cylinder. Which of the following are considered skew lines? So skew lines are any lines that are not parallel or perpendicular to the others. So every edge, AE, AC, AB, and AD are all skew lines. So AB, AC, AD, and AE are all skew lines because it is not parallel or perpendicular to the base. What is the base plan for this set of stacked cubes? So if you notice, you have a set of stacked cubes on the back that is 3 high. Then all the rest are 1. If you flip it up, where you're looking at the bottom, okay, it would be 1, 1, 3, and 1. So figure 2 is your answer there. Okay, you can also do it kind of from the top, looking down, and it will also give you the same figure. The front view of this figure, so if you're looking at it from the front, everything else is like smashed up next to it. You would see that this one is 3 deep, 1 deep, 1 deep, 1 deep. So this 3 is this one, and this one. So you'd have 3, 1, 1, 1. So this one would also be front. Figure 2. Which solid does the net form? So these are two circular bases and a rectangular side. Okay, the two circular bases could only be either a cone or a cylinder because it's the only ones, they are the only ones with a circular base. A cone only has one base. A cylinder, spelled that wrong, has two bases. So because this one has two bases, it is a cylinder. which solid does this net form? So it has 1, 2 rectangular bases. So it's a rectangular something. It can either be a prism or a pyramid. Well, I could see that it's going to fold here, and these two are going to fold up, fold the end, and this is a prism because it does have 2 bases, whereas a pyramid only has 1. What is the surface area of the given figure? So the surface area, the way I do these may be a little bit different than the system teaches you to do it, but I wanted to walk you through what I do on mine. So I want to start with the triangles on the end. We know that the triangles area is 1/2 times base times height. The base is 8, the height is 3. So 1/2 of 8 is 4, times 3 is 12. Okay, so each one of those is 12. So I've got 12 and 12. I'm going to list these over here. I've got 12 and 12. And now I've got to find this length. It's not automatically 8, but I need to find it. And I'm going to do that by redrawing this part of my picture right here. So I know that this is half, it's 4, and this is 3. So I'm going to do Pythagorean theorem to find out the hypotenuse. A squared plus b squared equals c squared. So 3 squared is 9, 4 squared is 16. Then I'll take the square root of both sides. So c equals 5. So now I can find the area of this side and the side back here. Because if you notice these 2 congruent lines, they tell me that those 2 are equal. So the area of those 2 rectangles are 5 times 12 because it's length times width. And that tells me that's 60. And so I'm going to write those over here to add them up. And then all I need is the bottom. Now the bottom is 8 centimeters wide by 12 centimeters long. So 8 times 12 is 96. So I'm going to add that over here. And then I'm just going to add them all up. 12 plus 12 plus 60 plus 60 plus 96 gives me the surface area is 240 centimeters squared. Use the net to find the approximate surface area of the cylinder. So on this one, we're going to find the area of the circles, and then we have to find the circumference of the circles to find this length. So let's go ahead and do the circumference. It's pi times d, or pi times 2r, 2 pi r. And our radius is 3. So if I multiply that out, 2 times 3 times 3.14, I get 18.84, and this is meters squared. Sorry, just meters. And so I can find the area of this by multiplying those together. And I get 169.56 meters squared. Now, we found the area of the rectangle there. So now we're going to find the area of the two circles. So that is just pi r squared. And so I've got 3.14 times the radius squared, which means times itself. So 3.14 times 3 times 3 tells me the area of one of those is 28.26 meters squared. And I have two of those. So I'm going to add 28.26 plus 28.26 plus the area of our, that's 9, of our rectangle there. And I do get 226.08 meters squared, and it would like it to the nearest square meter. So 226 meters squared, and that is the surface area. Okay, what is the volume of this prism to the nearest whole unit? So the volume is length times width times height. The length is 6, the width is 3, and the height is 4. Now, because of the commutative property of multiplication, you could put these in any order. So it doesn't matter if you said the 3 was the length or the 4 was the width. It does not matter. So you're just going to multiply them out. 6 times 3 times 4. And we do get 72. And volume is always cubed. Now we're going to find the volume of the prism. Now the prism, you're going to find the area of the base and then multiply it times its height. So the bases are two triangles. We know the volume of a triangle is 1/2 times 9 times 12. It's 1/2 times length times width, or length times height. And then we're going to multiply that by the height of the prism, which is 18. Okay, notice the 18 does not match up with the triangle. That's why it's off at the end. Okay, so we're going to multiply these out. 1/2 times 9 times 12 times 18. You do get 972 centimeters cubed. Remember, volume is always cubed. Okay, now we're going to find the volume of a cone. So the volume of a cone is 1/3 times pi r squared times the height. So same thing, 1/3, because remember pyramids and cones, you have to multiply by 1/3 because they're not the full prism. They are only taking up 1/3 of the space, times the area of the base, which is pi r squared, times the height. So we're going to write this out. 1/3 times pi, 3.14, times the radius squared, 3 times 3, times the height. So 3.14 times 3 times 3 times 11. And you can either multiply by 1/3 or divide by 3. Both of those work and give you the exact same thing. Now we're going to look at the volume of a pyramid. So remember, the volume of the pyramid is 1/3 times the area of the base times the height. So 1/3 times 2 times 2, which is 4, times 3, which is 12, times 1/3 is 4, and that is centimeters cubed. What is the slant height for the given pyramid to the nearest whole unit? We are going to have to treat this as a triangle to find the slant height. So this length down here is half of the side length. So if the side length is 28, half of that would be 14. So now we have to use Pythagorean theorem. A squared plus b squared equals c squared. A and b are both the legs. So that would be 14 and 48. And then we are looking for the hypotenuse, which is our c. 14 squared is 196. 48 squared is 2,304. And when we add those together, we get 2,500. Now we have to take the square root of both sides in order to get c by itself. That is the inverse operation of squaring something. So now the square root of 2,500 is 50. And the square root of c squared is c. So 50 inches is our slant height. What is the length of the diagonal for the given rectangular prism to the nearest whole unit? So what we're going to do is we're going to create the diagonal from this side to this side. That way this will still be a right angle. We could still use the Pythagorean theorem. We know that the height is 14. We know that the width is 6. And the length is 16. So now I'm going to find the length of the diagonal. So I'm going to say 6 squared plus 16 squared equals c squared. So 6 squared is 36. 16 squared is 256. And when we add those together, we get 292. Then we have to take the square root of both sides. And the square root of 292 does give me 17.08. We'll just say 17. Okay, so that is the length of this one. Now, we are going to I'm going to change colors so it's easier to see. We're going to do this triangle now. Ooh, sorry about that. Beautiful triangle there. So we've got 14 squared. The other leg is 17 squared. And we're looking for the diagonal there. So 14 squared is 289. The cones below are similar, although they are not drawn to scale. What is the length of the radius of the larger cone? So, we have a proportion of the small cone. I always want to put the small on top over the bottom, or over the big number, I guess we could say. So 10, or the big cone, over 18. So we've got 10 over 18 equals 5 over x. So we're going to do the butterfly is what I've always called it. Cross products, 10 times x and 5 times 18. When you multiply 5 times 18, you get 90. And 10 times x. To undo 10 multiplied by x, to undo it, you divide by 10. 10 and 10 divide to give you 1. 90 divided by 10 leaves you with 9. And we are dealing in feet. So the radius of the larger cone is x equals 9 feet. A cone has a radius of 40 and a volume of 1,875 centimeters cubed. What is the volume of a similar cone with a radius of 20 centimeters? So our original is 40, and the new is 20. So that would simplify to 1 over 2. Because volume is cubed, it's dimension times dimension times dimension, 3-dimensional. R2 will be the scale in every dimension. So it will be used 3 times, or 1 over 2 to the third. If we were doing area and there was a scale, it would be something squared, because area is only in 2 dimensions, whereas volume is in 3. So our scale is 1 over 8. So now all I'm going to do is take the 1/8 and multiply it by 1,875. And I do get 234.375. What is the surface area of a sphere with a radius of 6 meters rounded to the nearest square meter? So we're looking for the surface area of a sphere. So we've got to use our formula for pi r squared. So we have 4. We're going to multiply 3.14. The radius is 6. And that is squared, so we multiply it twice. So we're going to say 4 times 6 times 6. What is the volume of a sphere with a radius of 6 meters rounded to the nearest square meter? So the volume of a sphere, we have to use our formula. 4/3 times pi r cubed. So 4/3 times 3.14 And our radius is 6, so I'm going to multiply that 3 times. So I'm going to say 6 times 6 times 6 times 3.14 times 4/3. And I do get